Welcome to Solar Studies course. In last lecture, we have seen the how formation of the P and N type silicon, how we have to join together, how we can make the P and N junction and put together, why it is called as a donor atom, what is the N type material, that and all you have seen in the lecture 6. Now in this lecture, we will see what is the PN junction. Due to this one, how we can form a PN junction diode and what is contributed for the solar cell and diode equation, also solar equation. That and all you will see in this lecture. Welcome to lecture 7. Myself Karthikam. First of all, we will see what is the PN junction. I already told how it will put together and all, and it's working. We will see here, and how it become diode. And later we can see the diode equation. Then we will see about the ideal solar cell equation. Then ideal solar module equation. Then equation of real solar module with the series resistance and shunt resistance. That and all see in this lecture. First of all, what is the PN junction? I already told that we will take silicon. There will be doped with the some positively charged like which containing the less amount of electron. We will dope together. So what we can do in generally, we will take the p-type material. Suppose if we take a boron as a p-type material, then what we will do, we will put a yes like silicon, we will put there in the p-type material. So now what will happen, the p-type material induced with the n-type material, so that form p and n complete formation. This is called p and n junction. So when light is incident or any some amount of energy is given to this P and N junction, as you know, electron starts moving from one side to another. Then what will happen when more number of charge is incident or any light is incident in here, it starts moving from positive to negative, negative to positive. At this middle region, it form P layer and N layer. In P side it form more number of electrons are accumulated and N side more number of holes are accumulated. This is called junction. This form the junction in the P and N material. So whatever the electrons are present in this junction, this is called mobile electrons, and this complete region is called as a depletion region. See, Dn, it is negatively charged but holes are accumulated. Dp, this is positively charged but electrons are accumulated. So when electron is want to go from positive to negative, it starts from here to here. It is easy to take recombination. So movement of electrons to the p side is exposes positive ion cores, and n side it will be a n ions. So finally p and n junction will be formed. This small part we will call as a depletion region. So due to this movement of electron, a small amount of voltage will be produced during this recombination of electrons and holes. So same thing, if I put together P and N type material, if I put together, then it form basic P and N junction diode. In this one, it containing the more number of holes in the p side, electrons in the n side. So majority of carrier can diffuses across the pn junction that form the depletion region. Even though electric field impedes their crossing, minority carrier that reach the junction and swept across the depletion region. This is due to drift. How, like if some amount of energy is applied to that junction, that it starts moving, then small amount of electrons accumulated at the p side. This is called the Mobile electrons, I already told. When there is no electricity or anything is applied, that is in the equilibrium state. At that time there is no electrons hole pairs taken. So at the equilibrium the net current is zero for both electrons and holes. So the diffusion of a current is equal to the opposite to the drift current for the both the carriers, because each carrier is having some amount of carrier. When it is attracted, like positive is attracted towards the negative, it starts coming to closer. When there is no any incident electricity or photon, then it will be in the equilibrium state. Now we will see how conduction of the Pn junction will happen. See, this is P side, this is N side. Okay, here it containing the hole. Okay, so positively charged. This is negatively charged electron. What I will do, I will apply some voltages. Okay, from here. First of all, this is positively charged, this is negatively charged. I will also apply the positive voltage here and negative voltage here. So what will happen in positive means here also it containing the holes. Let's assume some certain amount of the voltage is applied with the holes. It starts moving like this. When holes is reached here, it is also try to goes to here, but we know that positive and positive never attract, positive and negative will attract, so it is repelled to each other. Okay, so what will happen if amount of voltage is increases here, it is repel. So what will happen, it goes like this direction. Due to more number of holes are coming here, all the holes are started moving towards this direction. Then what will happen, finally it will goes to this n region because of this repelling. Now here positively charged holes are accumulated. Then similarly when negatively charged voltage is applied, it is also moving here. Okay, so when more number of electron is coming here, like negatively charged, it is also moving towards this direction. Now electrons are accumulated here due to repelling of each other, negative to negative repel. Okay, negative to positive attract. So again due to this one it will move this side. So what will happen, at this side there will be a region is forming which containing the positively charged holes, negatively charged electron. So when more number of electricity we are giving, it starts moving this direction. So electrons are moving in this way. So generally it started producing current. So we have to know that if electrons moving in this direction or any direction, current is moving opposite direction. So now what will happen, electrons are moving in this direction, these holes are started moving here, so current will be produced. Okay, so another thing, now what we have seen how to generate current, we have seen that one. Okay, suppose if I give negative charge to positive side, P side. Okay, and positive charge to negative side. What will happen? Let's see. Here holes are coming. So holes are going in this direction because it is negatively charged. Electrons are present. So holes and electrons are attract each other. So minus and plus are attracted together. So what will happen? All the electrons starts comes to near this positively charged hole. So it form this vacant place. Similarly, when electrons are moving here, these positively charged holes also started coming here. They all are accumulated in this side. All the positive are accumulated here. So all the negatively charged electrons are accumulated here. This form one region. This is also form depletion region, but there is no any electrons or holes are present. Okay, this is completely vacant. Okay, so in this case there is no conduction. There is no conduction in the reverse of the polarity. We can see that then. So finally what we will conclude that if I put positive to positive and I will tell you how. P-type material will be added positively charged holes and N-type material added negatively charged electron. Like polarity is plus at the P side, polarity is N is the negative is the N side, then it is called as a forward bias. When it is in reverse, when P is applied to negative polarity and N is applied by positive polarity, it is called reverse bias. Okay, so in forward bias there is a conduction. In reverse bias there is no conduction. It is maybe we can call it a it is act as a insulator. So this is the basic for conduction of the electricity in the any P and N junction diode. This PN junction diode is nothing but we can always call as a basic of a solar cell. So I already told that how to give a positive charge to P side and negative charge to N side. This is called biasing of the junction. I explained how P is attracted to P side, like actually it goes to P side, and E negatively charged electrons is going to N side, and how it will repel and how conduction will be happening. So when forward bias there will be a circulation of current. In reverse bias there is no circulation of current. Now we will see the diode equation. This symbol is indicate the basic forward bias P and N junction diode. This side is P side, this is N side. Okay, so now D is the current flowing in this diode, that is given by I sat. It is nothing but saturation current which is formed in the PN junction diode and multiplied with the charge of electron and voltage inside the diode, that is called as a thermal voltage, and divided by K. K is nothing but Boltzmann constant, T is the temperature, and this equation is applies all type of diode. So basically we know that this is nothing but PN junction device. So it can be represented as a like this symbol. This is called P side, this is called N side. If I biased this one, this is also conducting in the only one direction. If I applied reverse bias like this, it is not able to conduct. So this is basically called as a PN junction diode. Okay. The current flowing in this diode is called as a ID. So how we can derive this ID current? That is nothing but ID is equal to, so current in this saturation of electron, that is I can call it as a I sat into e to the power of QV divided by K into T, okay, minus 1. So what is the Q? Q is the charge of electrons, that is 1.602 into 10 to the power of minus 19 joule, and V is any applied voltage in between. Okay, then K is Boltzmann constant. Okay, that is given 1.38 into 10 to the power of minus 23, and T is the room temperature, or if I get any temperature is incidenting, that will consider here, it is T is in Kelvin. Okay, so 0 degree is nothing but 273 0.15 Kelvin. So basically we can consider as a 273 for standardized, that is called 0 degree. So standard room temperature like 27 degrees Celsius, we can call it as a 300 Kelvin. Okay. Like this our equation has been formed. Now let's consider ideal solar cell equation. How? See, in this one, this is nothing but P and N junction. That is basically diode. So solar cell is also a format of a diode because it is also containing P and N. So, but in this one, instead of this diode current, what we have? We have photon current which is coming from the sun. That is called as a IPH. So, if I use KCL, Kirchhoff current law, we will get this type of equation, that current coming from this node is nothing but current entering into this node minus current leaving in this node. I will tell you how we can do this equation. So, first we know about the diode current, right? Yes. So, diode current is coming like this. This is also same as a solar cell. Okay, this is PN junction is nothing but solar cell. So what will give? There will be some incident photon that is coming like this. So basically a photon is incidenting on this direction. So we can call it as simply in this direction. So this form a node. So according to KCL, current entering a particular node is equal to current leaving from that node. Okay, we will tell how. So we will make like this. This is one node. This current is I am getting I. This is diode current. Okay, this is photon current IPH. So I want to get I. How I can get I? I is equal to this current is entering this node. Okay, that is plus IPH. I can give any symbol. Then from this node, this much of current ID is coming from this node. So I can subtract this diode current. So if I apply this ID equation, then I will get the total current of the solar cell. Now what we can do, we know the equation. ID is equal to I sat into, because it is exponential term, so I have used e to the power of qv divided by kt minus 1, right? Okay, so let's take this numerator. If I want to consider only this one, because these all are constant, so what we can do, I can replace this by Vt. This is, I can call it as a thermal voltage because it containing the temperature term, and it is depend on my temperature, that may be room temperature or temperature of incident light. So I will get Vt is equal to Kt divided by Q. So basically this equation I can write it as ID is equal to Is e to the power of this V divided by this Kt by Q, because Kt was in denominator here, it will be numerator, so I can make it as a denominator Vt minus 1 for simplification. So for solar cell also same, I is equal to, here not ID, I, that is nothing but IPH minus this ID. So now we got the ideal solar cell equation. So as I told that, if I want consider as a thermal voltage with some room temperature, I can replace by Vt. It is like a same equation. Now I got the ideal solar cell equation. Now if I connected number of solar cells like this, so what I have to do, I have to just add a number of cells. If I having two cells, I have to put 2 in this equation. If I get a 10, I have to add n cell is nothing but a number of cells in the series connection. If I got 10, I have to put 10. So in order to make a module, I have to connect this kind of such a number of cells. So voltage terminal at the each cell is divided equally among the each cells. Okay, like this will consider, if I am getting some constant voltage around 36, so each cells having same voltage. How much? 0.6. Okay, because forward bias of the solar cell or ideal diode, the voltage required for conducting it is 0.6 volt. Let's consider ideal diode. See, in order to getting current from this diode, I have to supply minimum amount of voltage. So from that voltage, electron starts moving here, we will get the current. So this minimum voltage of diode is 0.6 volt. So in order to form solar module like this, it containing number of series diode. This all the diode or solar cell form a one single module. In single module, it contain 60 or 72 series of cells. Okay, so each cell having voltage 0.6 volt. So ideally it is giving 36.6 volt. for 60 cell. For greater like 72 model, it is giving more than 66 36 voltage. Okay, so in order to form module, we required series of connection of a diode or solar cell. This is nothing but solar cell. For basic, we will consider as a diode. This is also Pn junction, and solar cell also containing Pn junction. So in case I suppose tell diode, it is nothing but solar cell. Now we learned about the ideal solar cell. Okay, here IPH will comes. This is called diode current. This is photon current. This is current coming out from this solar cell. Suppose if I want to resist some current, so I will put some series resistance. Why? Because sometime due to high photon I will get some high current that may damage the system. For that reason I will put some series resistance. Okay, in order to prevent some high spikes, so it will resist the current. Okay, now what my equation become? Then I will get is IPH minus ISAT into e to the power of, I will take VT, and if I get more number of cells I will add n cell, then V minus 1. This is the basic equation. But if I get the resistance, then what I have to do? I have to modify this equation. How? This is nothing but, let's see, this is voltage across these two terminals. So this voltage will become added up using this. So we know that V is equal to I into R, right? So here in the case we get IRS. So now what we will write, this is previously contained voltage, that is called V, and this amount of voltage will add up. So I will add this. Suppose I will make one V1, or V1 is nothing but I into RS if I add in series resistance. This is the new equation with series resistance, because in each solar cell it containing some series resistance in order to preventing the some currents. So all the modules containing n cells with one series resistance, because if I connect it in series for all diode, one series resistance will be sufficient. Now I will modify the circuit. Let's see. Okay. This is series resistance I have added. Now this is photon current. Okay. Now what will I do? I will add another resistance like this. We'll change the color. This is newly added resistance that is parallel. So what I will call it as a shunt resistance, that is called RSH. This is series resistance, that is called RS. Okay. Now this current is ID. Fine. Yes. This is IPH. Now this is current is nothing but flowing through this shunt resistance. This is, I can call it as IRSH, and this current will be now I. So this is voltage across this diode or solar cell. So what I will get the new equation, that is nothing but I is equal to, now I will take this as a node and this also another node, but here current is again distributed. So I will be call it as a current entering this node, that is IPH plus IPH. Now current flowing in diode, that is negative ID. Then again it is coming from this node, because these node are same. It can be, this is like big node, we can call it as a. So again current through series resistance is IRSH. So I is nothing but V divided by R, right? Because V is equal to I into R. Then if I want I will take to here. Then it will become V divided by R. So in this case, ISH will become V divided by RSH. But this V also presenting here. This is I will get another V. Okay. So I will add this current to here. So because I want to get final V, there will be addition of these two things. So then what I will get? I will get ISH is equal to V plus I into RS divided by RSH. Okay, because this is used V here. So then final V equation is equal to IPH ID. ID is nothing but e to the power of V plus IRS, because it is also containing series resistance. See, suppose this is cell, it containing series resistance now and parallel resistance. So I have to include series resistance here, then VT into number of cells minus 1, then this one. Okay. So finally, this is with the RS, we will have got this equation. Then with the series resistance, if I get the more number of series resistance, I have to add it. But I already told that all the module having completely one series resistance finally by adding all the series resistance. Then if I add series resistance as well as parallel resistance, see, this is IPH, this is ID, this is ISH, then final current is flowing through this RS. Then final equation I will get I is equal to IPH minus ISAT into e to the power of V plus I into RS divided by N is a number of cell into Vt minus 1. I will tell you what is this eta. This is nothing but ideality factor. To satisfy this equation, we have containing some ideality factor to getting some actual current according to our requirement. So we have used this ideality factor. Then this RSH, that is nothing but V plus voltage across this plus this IRS divided by RSH, then I will get the total voltage. So here there will be 5 device dependent parameter like what and all, RS, RSH, V, eta and IPH. So I already told that why we need shunt resistance. Shunt resistance is given to PN junction for give alternative current path. Suppose if it is not possible to this here, like it is using series resistance, I have to get alternative current path here, then it will goes from here. So in this course we learned about the basic ideal diode equation, diode cell equation and solar cell equation also. Then if I get number of cells, then I can make a model, so that, so then we will get the module equation also. So that and all you see in the next lecture. Let's see, using this equation what we can do, how we can get a voltage and current curve in a solar cell, that we will see in the next lecture. Thank you.